Hi, in this video lecture we are going to solve some examples based on Green's theorem. So in this example we have to verify Green's theorem for single integration of 3x minus 8y square dx plus 4y minus 6xy dy, where C is bounded by three lines. The line x is equal to 0, y is equal to 0, and the line x plus y is equal to 1. So the curve is a triangle and the surface is the triangular surface which is bounded by three lines. The line x is equal to 0. Let's understand by the diagram. The line x is equal to 0, which is y-axis. The line y is equal to 0, which is x-axis. And the line x plus y is equal to 1, which is traced by joining the points 1, 0 and 0, 1. So it is a triangle. The surface is a triangle which is bounded by three curves. And according to Green's theorem, the statement is that integration of phi dx plus psi dy is equal to double integration of del psi by del x minus del phi by del y dx dy over the surface S, where the surface S is bounded by the given curves. And for this question, the value of phi, as we can see, it will be 3x minus 8y square, and the value of psi will be 4y minus 6xy. And in order to verify Green's theorem, we have to show that the left hand side is equal to right hand side. So starting with left hand side, so to evaluate left hand side along the curve C, it has to be splitted into three parts. First along OA, which is the line y is equal to 0, then along AB, which is line AB, and the third along BO, which is line x is equal to 0. So the left hand side is now it has three parts: along OA, along AB, and along BO, where phi is 3x minus 8y square and psi is 4y minus 6xy. So along OA, as we can see, along OA the value of y is 0, therefore the value of dy will be 0. And we have to integrate this, that 3x minus 8y square dx plus 4y minus 6xy dy. So we put along OA y is equal to 0 and dy is equal to 0. Therefore the integration is now 3x dx. And let's find the limits of x, since we have to integrate with respect to x. Since along O to A the limits of x will be, as we can see, from 0 to 1. Therefore the limits of integration will be from 0 to 1 along OA. And when we integrate this, it will be 3x square by 2 between the limits 0 to 1. And when we apply upper minus lower limits, it will be 3 by 2. So along first curve, the value of integration will be 3 by 2. And the second line is the line AB. Let's see the diagram. The line AB, whose equation is x plus y is equal to 1. Therefore in place of y we can put 1 minus x, and in place of dy it will be minus dx. And if we integrate with respect to x, let's check the limits of x. So here at point A the value of x is 1, and at point B the value of x is 0. Therefore the limits will be from 1 to 0. So along AB, let's evaluate the single integration. So we have discussed that along AB the line is x plus y is equal to 1. Therefore in place of y we can put 1 minus x, and in place of dy it will be minus dx. And the limits of x, we have seen that it will be from 1 to 0. Therefore the integration is now integration from the limit 1 to 0, 3x minus 8, and in place of y square we have to put 1 minus x whole square dx minus 4. In place of y it will be 1 minus x minus 6x, and in place of y it will be 1 minus x, and in place of dy we have to put minus dx. And if we take dx as common, finally if we open all the brackets, the integration is now integration between the limits 1 to 0 minus 14x square plus 29x minus 12 dx. And when we integrate it with respect to x between the limits 1 to 0, the integration is now minus 14 by 3x cube plus 29 into x square by 2 minus 12x between the limits 1 to 0. And when we apply upper limit minus lower limit, the value is finally along the line AB, it will be minus 13 by 6. And the last curve is along BGO. So let's check the diagram. So the third curve is, as we can see, it is the curve BO, and here we can see the value of x is equal to 0, therefore the value of dx will be 0. And this time the integration will be with respect to y, and for the limits of y, the starting point is b and ending point is o, therefore here the value of y is 1 and here the value of y is 0. So the integration with respect to y, the limits of y will be from 1 to 0, and along BO x and dx will be 0. So let's evaluate the integration along the line BO. So along BO, x and dx are 0 and the limits of y is from 1 to 0. And when in the functions 3x minus 8y square dx plus 4y minus 6xy dy, if we put x is equal to 0 and dx is equal to 0, the value of integration is now integration of 4y dy between the limits y is equal to 1 to y is equal to 0. And when we integrate this with respect to y, the integration is 4y square by 2. And when we put upper limit minus lower limit, the value of the integration is now minus 2. Therefore the whole left hand side along the triangular curve, the integration of phi dx plus psi dy will be integration along OA, along AB and along BO. So the values were 3 by 2 plus 13 by 6 minus 2, which is equal to 10 by 6, and finally the value of left hand side is 5 by 3. So this is our left hand side, which is equal to single integration of phi dx plus psi dy along the given curve. Our left hand side is equal to 5 by 3. Now since according to Green's theorem, it must be equal to double integration of del psi by del x minus del phi by del y uh, over the surface S, which is bounded by the given curves. So we have to now evaluate del psi by del x minus del phi by del y uh, over the surface S, which will be bounded by the given curves. So it will be del by del x of psi, and the value of psi is 4y minus 6xy, minus del by del y of phi, and the value of phi is 3x minus 8y square dx dy. So when we partially differentiate this and differentiate this part with respect to y and subtract them, uh, the differentiation of 4y will be 0 and the differentiation of this will be minus 6y, and here the differentiation of 3x will be 0 and differentiation of 8y square will be 16y. So the integration is now minus 6y plus 16y dx dy, which is 10y dx dy. Now for limits, we have to see the diagram how to find limits of y and limits of x. So let's check the diagram for the limits of x and limits of y in double integration. So this is a diagram, and wait a minute. So this is the surface S over which we have to evaluate the right hand side whose value is double integration of del psi by del x minus del phi by del y dx dy, and we have calculated this function, and it is equal to 10y dx dy. And now we have to find out the limits of y and x using the diagram. So to find the limits of y, this is the surface, so we make a strip which will be parallel to y-axis. So this will be the lower limit of y, and this will be the upper limit of y. So we can see the lower limit of y is on x-axis, and here the value of y is 0, and this is the upper limit, and here the strip touches the line x plus y is equal to 1. So this is the line x plus y is equal to 1, and from here the value of y will be 1 minus x. So the limits of y will be from y is equal to 0 to y is equal to 1 minus x. And here we have to make our first vertical strip, and here we have the last vertical strip. So the limits of x will be from this point up to this point. So here the value of x, as we can see, this is the point 0 0, therefore the lower limit of x will be 0, and this is the last point up to which we have to make the vertical strip to cover up the whole surface. So here the value of x, as we can see, it is 1 0, therefore the value of x is 1. Therefore the limits of x will be from 0 to 1, and the limits of y will be from y is equal to 0 up to this line, from where the value of y will be 1 minus x. So the limits of y are from 0 to 1 minus x, and the limits of x are from 0 to 1, and from these limits we have to evaluate 10y dx dy. So let's move forward on right hand side. So we have calculated all these values, and we have found the limits using the diagram. The limits of y are from 0 to 1 minus x, and the limits of x are from 0 to 1. And order of integration will be first integration with respect to y, and the second integration with respect to x. Since y has variable limits, that is 0 to 1 minus x, so we first integrate the function 10y with respect to y, treating x as a constant. So the integration of 10y will be 10y square by 2, and the limits are from 0 to 1 minus x. And when we put upper limit minus lower limit, the integration is now 5, integration between the limits 0 to 1, 1 minus x square dx. When we put upper limit minus lower limit, this value will be 5, 1 minus x square. And now we have to integrate it second time with respect to x. So before integrating, we open the bracket using the formula a minus b whole square. So it will be single integration between the limits 0 to 1, x square plus 1 minus 2x dx. And when we integrate it with respect to x, the integration will be now it will be x cube by 3 plus integration of 1 will be x minus 2x square by 2 multiplied by 5. And when we apply upper limit minus lower limit, the value of integration is now 5 by 3. And since our left hand side was also 5 by 3, therefore we have shown that the left hand side is equal to right hand side. Therefore we have proved that single integration of phi dx plus psi dy is equal to double integration of del psi by del x minus del phi by del y dx dy. Therefore our Green's theorem has been verified.